Okay, we are now going to calculate the rate of change or determine the rate of change from graphs. We have a graph on the screen here that says determine the rate of change. And the rate of change is the same as slope. Those two things are interchangeable. I could just easily say determine the slope. And in order to determine slope, we need 2 points from the line. We can pick as many as we want, but we only need 2. 2 would be sufficient enough. And with these graphs on your quizzes, we want to make a note here that the arrows point to points on the line. I know it looks like there are some other points on the line, like it looks like this might be a point. We're not so sure. It's hard to kind of tell. We don't have that indicated whether it is or not, but we can say with certainty that the arrows point to points. So this point is on the line. This point is on the line. At least that's what we are trying to convey to you, that those 2 points are on the line. So keep that in mind when you're picking your points. So I'm going to pick those 2 points because I only need 2 points to determine the rate of change. So I'm going to find the coordinates for this point. So I start at the origin. I go negative 1, 2, 3, 4, 5, 6, and then up 1, 2, 3, 4, 5, 6. So the coordinates for this point are negative 6, negative 6. And then the coordinates for the other one are going to be negative 3, 7, which we can verify. Negative 1, 2, 3, and then down 1, 2, 3, 4, 5, 6, 7. The coordinates for that point are negative 3, negative 7. And if we want to find the rate of change between these two things, we are going to use our slope formula, which is the difference of the y's divided by the difference of the x's. So I'm going to go 6 minus negative 7. Take the difference of the y's, this is a y value, this is a y value, and do 6 minus negative 7. That's what we have here. Divided by the difference of the x's, negative 6 minus negative 3. And then we do the arithmetic that we see. Negative 6 minus negative 7 is 13. Negative 6 minus negative 3 is negative 3. And the rate of change of this graph is 13 over negative 3. And that can't be reduced at all. We do not want to change it to a decimal. We want to leave our rate of change or our slope as a fraction. So negative 13 over negative 3 would be the rate of change for this line. Another example, which of the following lines has a slope of 3? We have 3 graphs given to us, and we want to know which of the following lines has a slope of 3, and we want to make a note that this is a positive 3. So just by the fact that this is a positive 3, I can eliminate 2 answers right away. I can eliminate this one. And the reason I can eliminate this one is because this line has a negative slope. If we read it from left to right, it's going down from left to right. So that's not a positive slope, so that cannot be the answer. Another one we can eliminate is this one, because this also has a negative slope. This line is going down from left to right. So neither of those two can be our answer just by the fact of the very basics of slope, that this is a positive slope. These lines have negative slopes, so those cannot be right. So we're down to 2 more, and I'll make these a little bit bigger. I just kind of enlarged this one here, and I've enlarged this one here, and we want to find which has a slope of 3. Now we want to make that 3 into a fraction ideally for slopes. That would be like a 3 over 1. So 3 over 1. So our rise over run is going to be 3 over 1. So if I pick a point on, let's say, this line right here, this is a point, and let's say that's about negative 3. And if our rise over run is 3 over 1, if I go up 3, so if I'm at this point here, and I go up 1, 2, 3, and then I go right 1, rise over run is 3 over 1, this is where I end up, and I am no longer on that line. So if I start here and go up 1, 2, 3, and then right 1 by using our slope, rise over run, I'm not ending up on that line. Whereas if I pick this one here, I pick this point, I'm at negative 3, and if I go up 1, 2, 3, and then right 1, oh, I am on the line. If I go up 1, 2, 3, and then right 1, I'm on the line again. So this cannot be our answer, and this is the line right here that has a slope of 3. It's a positive slope. It's going up from left to right, and if I treat our slope as a fraction, rise over run, up 3, 1, 2, 3, and over 1, I'm ending up on the line. 1, 2, 3, over 1, and I'm ending up on the line.